Hey guys, all right. This is our next lesson for Unit 5. This title is called Solving Easy Exponential Functions. So what we want to start with is the equation, okay? If b to the x power equals to b to the y power, then with common sense, x must be identical to y, okay? So x and y should be the same if the bases are identical. So with that equation, we can use it to solve the following problems. Now, the guidelines to solve the following problems are: isolate the base, so you want to get the base all by itself. Write each base as a power of common base. Set exponents equal to each other if the bases are the same. That's what it means by common base. Then you can now get rid of the bases and just take the exponents and set them equal to each other, and then solve the equation. So let's start with, we have 1, 2, 3, 4, 5, 6, I believe. Example 1, 3 to the 5x minus 1 equals 81. As you can see, 81 is not the same as the base of 3. So it said, okay, well, the bases are not the same right now, so what we want to do is make the bases the same. Well, the prime number is already 3, so we can't really make that any smaller. But 81, I can make 81 to base of 3 because 81 is technically 3 times 3 times 3 times 3, 4 times. Well, anything multiplied 4 times, that's the same thing as saying 3 to the 4th power. So now the bases are exactly the same. You can, guess what? Drop the bases and set the exponents equal to each other. And then from here, you solve for it as normal. So add 1 to both sides, 5x equals to 5. Then divide both sides by 5, x comes out to be 1, just like that. Okay. Number 2, 4 raised to the power of a plus 3, take away 7, equals 25. Well, as you can see right now, this is not alone. So the first step is we want to get the bases alone. So add 7 to both sides. Okay. So now we have 4 to the a plus 3 equals 32. Well, 4 is not quite a prime number, so 4 is really 2 squared. So we always want to break it down as low as we can, so write it as prime number. Now 32 is not the same base as your 2, so now we want to break 32 to see if we can break it down to base of 2. Well, 32 is really base 2 to the 5th power. Now, as you know already from our last unit, power to the power, you want to multiply. So this is 2a, and that's going to become 6. So 2 to the 2a plus 6 equals 2 to the 5th. Now the bases are now exactly the same. You can drop those bases and just take the exponents and set them equal to each other. So 2a plus 6 equals 5. Subtract 6 to both sides. 2a equals to negative 1. Divide both sides by 2. A equals to negative 1/2. And box that up. Remember, you can always pause these and then write down the work, okay? If I'm going too fast, don't feel rushed. You can always pause it or rewind or listen to it again. Next example, 3 to the power of x equals 3 to the 2x plus 7. Now, as you can see, the bases are already the same, so we can just drop the bases because they both have a base of 3. Somehow I can't highlight. You know what? There you go. I think I'm just too stretched out. Every time I stretch it out too much, and then it doesn't like it. Let me pinch it back in. Hold on. It's not letting me pinch in. Oh, there you go. Now it's you pinch in. There you go. Just like that. So I'm just going to drop the bases from here. So now, whoop, I didn't want highlighter. So now we will take x, which is the exponent on the left side, set it equals to the exponent on the right side, which is 2x plus 7. And then solve for it normally. So we want to subtract 2x from both sides. So that's going to 2x, subtract 2x, and x take away 2x will give us a negative 1x. I'm going to pinch it back in again because it doesn't like that. So let's see if that helps out. There you go. Negative 1x equals 7. That means x is just going to get a negative 7 because we're dividing both sides by negative 1. Box that up. Next, 7 to the power n minus 3 equals 49. As you can see, it's already isolated, 7 to the n minus 3. 7's a prime number, so we don't have to worry about making 7 any smaller. But 49 is not the same base as 7, so convert 49 into 7 squared. Now, as you can see again, the bases here are the same, so we can drop them. We now would just take n minus 3 equals 2, add 3 to both sides. So now n must equal 5 for those to be the same. Now we got 5 to the, example 5 to the x minus 4 equals to 1 over 25. Well, you can think of it as, well, 5 is already a prime number, so we can't really make that any smaller. But 1 over 25, that's a fraction, and it's under 1. So a fraction under 1, we can rewrite it as a negative 1 exponent. Because remember, when you have something reviewing here, you have x to the negative 1, that's the same thing as 1 over x, right? Or you have, if you have 1 over third to the negative 1, that's the same thing as 3, just a review. So now we're making it as 25 to the negative 1. Well, 25 is not the same base as 5, so we want to make 25 with the same base, which is 5. 5 squared is 25, and it's still raised to a negative 1. So power to the power, we would now multiply 2 to negative 1. Well, that's going to give us negative 2 power. Well, they both now have bases of 5, so we can drop them completely. We now have n minus 4 equals negative 2. Add 4 to both sides, so n equals negative 2 plus 4. So this means n equals to positive 2. And that is our final answer for example 5. Our last one, it's very similar to the first 5. Well, 9 is definitely not a prime number. We want to rewrite 9 as a 3 times 3. That's 3 times 3 times 3. 3 times 3, right? Well, but 3 times 3, we want to write it as a power. So that way we can multiply to the y plus 7 later. Well, 243, well, that's a serious number. Well, 243 is technically 3 to the 5th. Power to the power again, don't forget that rule. You have to multiply these out because if you don't, you will get the wrong answer. So it's now 3 to the 2y plus 14 equals 3 to the 5th. Nothing we can do on the right side. Bases are now both 3. We can drop those. So now we have 2y plus 14 equals 5. Subtract 14 to both sides. So we got 2y equals negative 9. Divide both sides by 2. And that is as far as we can go for that piece. Y equals negative 9 over 2. Or you can give me y equals negative 4.5. Or you can give me y equals negative 4.5. Now only give me decimal if you can round that perfectly. And that concludes our lecture for this one.